Okay, review exercise 2 from unit 3. On the following slides, each slide actually, there will be a graph for a continuous distribution. Answer the series of questions below. So the first question is, looking at this red graph that you see here, is this the graph of the PDF, probability density function, or the CDF, cumulative density function, and how do you know? For each one of these questions, pause, answer the question, and then press play to go on. Well, it's the CDF. And the reason we know that is the CDF is going to start at 0 and in a continuous manner increase eventually up to 1, which this does. PDF will be 0 on both ends with an area of 1 underneath it. So this is a CDF, not a PDF. Compute the probability that x is less than 10 by looking at this graph and illustrate the probability on the graph. You should be able to get this to, say, 2 decimal places of accuracy, or at least within just a little bit. Press pause now. Okay, so the probability to the left is the actual y value. So if we find 10 on this graph right here, we go up and we're just reading off this y value right there, which turns out to be 0.25. So you're just going from here up to here and across. Or in other words, when you're going left, that's below. So you're going from the graph down to the x-axis, that vertical length, which is that purple length, which is the same as that y value, which is the same as the probability to the left, which is 0.25, 25%, 1/4. All right, how about the probability that x is greater than 12? What is that probability? Again, press pause, work it out. Okay, well, that probability is 1 minus the y value here, or it's the distance from the graph up to y equals 1. So we find 12 on here, go up and figure out what the y value is. Now, this one looks like it's pretty much on a line. So it looks like that y value is 0.45 or 0.44. It looks like it's slightly under, so I said 0.44. Subtract that from 1 and you get 0.56. You might have said 0.45 and gotten 0.55 here instead. If you can get that close for me on my exam, you're going to be fine. Because if I were doing this on an exam, I would know what the exact value is rounded off to 2 places. And then I would allow probably a couple, whatever the last digit is, I would allow to be off 1 or 2 either direction from that. As long as you can estimate those vertical lengths that closely, you're going to be good. Which is essentially estimating y values. Now, of course, vertically distance, that's the distance from the graph up to the line y equals 1, which is this purple distance. And that is the probability to the right, which is 0.56 here. All right, how about a probability between 12 and 14? The probability that 12 is less than x, which is less than 14. Well, this is a difference in 2 y values, so you just have to work out what these 2 y values are here and here and subtract them, or equivalently find this vertical distance here. And it looks like it's 1, 2, 3, 4, 5 of these little links. And if we look over here, 1, 2, 3, 4, 5 of those is 0.25. Or I could get the 2 y values. CDF of 14 is about 0.7. CDF of 12 is 0.45. Subtract that and you get 0.25. So it's this purple length, the difference in the 2 y values. So notice in all of these you can see probabilities as some sort of vertical length. All right, so again, here we have the same graph. If the probability that x is less than a equals 0.8, then what is a? Press pause. Okay, well, this is an inverse probability problem. We know the probability to the left is 0.8, and we want to output the a value. So it's an inverse probability of 0.8. Well, So that means 0.8 is the y value. Find it right here. Come across the graph to here, and we come down. And we're going to have to estimate what that is. Okay, so come straight across and then straight down. Now it's something between 14.5 and 15. So there's 14, there's 15, there's 14.5, 14 point, I'm going to say about 14.7, 14.8. Might have been a good guess too, but to the 10th, I think we can get it pretty close there is about 14.7. So it's the x value when y is 0.8 on the graph, okay, and then the probability to the left of that is the 0.8. How about this one? The probability that x is greater than b is 0.1. Then what's b? Well, this is similar to the last one, except this time the 0.1 is the probability to the right. So if we take from y equals 1 down, it's 0.1. So from the x-axis up, that's 0.9, 1 minus 0.1. So the y value we're looking for is 0.9. So we'll take y equals 0.9 across, here it is, and we'll find where it crosses the graph, and then come straight down and find that x. All right, so there's 15, 15.5. I'm going to say 15.4. Okay, so 15.4 is the x value when y equals 1 minus 0.1, or 0.9. So 0.9 is the probability to the left, and 0.1 is the probability to the right. So that's how we can use a CDF, and this time we're just reading the values off of the CDF graph for reading y values and vertical distances. Probabilities, once again, are seen as vertical distances. Finding probabilities is essentially taking an x and finding a y, and either keeping that y, or doing 1 minus that y, or doing the difference in two of those y's, depending on which kind of probability, whether that's left, right, or between probability, respectively. And inverse probabilities, you always look at the y being the probability to the left. So we graph a horizontal line at y equals that point, that value, find where it crosses the curve, and then come down, and that corresponding x is what we're looking for the inverse probability problem.